Hey, I'm back. Uh, for anyone who was on this channel and they just kind of got bumped off of Zindaris' channel, yeah, he's doing a Drod playthrough, which is a game that I came up with back in the 90s. So if you are really into that, just go back to Zindaris' channel. You can see up in the chat window here how it's spelled. Zindaris. Zindaris. Or is it? Anyways, hey, I'm making a game. This is the second session of two so far in this day, Saturday, of me working on this game. Okay, I had one thought to share with you before I get to a little quick demo of what I just did in the first session, along with getting back to work. Okay, so the thought is meditation. There's many forms of meditation, and we generally use meditation to not improve ourselves in a permanent way, but maybe to put ourselves into an appropriate state that has some value to us. And I've actually discovered a new form of meditation. The technique is accessible to anyone. You don't have to study under me for multiple years in order to acquire this technique for yourself. In fact, I'll just teach it to you right now. It's only going to take a couple minutes. Okay? So, you want to have some connection with the misery that's in the world. And here's how you do it. Okay? You start out with an image of a group of people to whom some affliction has befallen, some bad times, you know? So let's start out, let's say, all the hungry babies in the world. There's got to be just a ton of hungry babies. I'm guessing like millions. So just picture maybe 2 million hungry babies, because that's my guess about how many babies are hungry right now, right at this very moment. And that kind of makes you feel something, right? Feel sad for those 2 million hungry babies, but it's too abstract. So you gotta narrow your focus a little bit as part of this meditation exercise. So you think, okay, about all the hungry babies with a single working mom who's busting her ass to try to provide for that baby, but just doesn't, it's barely able to bring food to the table for herself and her child. And then maybe that shrunk it down to 1 million cases. So now you've got a more concrete example of misery in your head, but still a little bit abstract. Okay, so now you're feeling bad about 1 million hungry babies supported by a hard-working single mom. Okay, that's not enough. Okay, so let's focus it further. Okay, all the hungry babies with a hard-working single mom supporting them on a hot summer day, just a blistering hot summer day. Oh my God, at least 100 degrees. Okay, so now we took a big jump there. Now it's down to maybe 50,000. Okay, you gotta get more specific because still it's just too abstract. You can't feel the pain yet. Okay, so I'm gonna jump over a number of steps here. Let's get real specific. I'm gonna bring the count down to maybe 7 hungry babies. Okay, so this is all the hungry babies with a hard-working single mom on a fucking hot summer day, who a kind vendor with his ice cream cart rolling by gave a free cone of ice cream to the baby, and the mom is there and she's smiling, says, "Thank you, sir, thank you for the helado or the ice cream," whatever, where it can be any place in the world. I think there's only 7 cases like this happening right now at this very moment, if I'm able to predict correctly. So it's a little spike of happiness in that baby's life, because that baby knows that that's ice cream and it's going to taste good. Babies, they just know. The baby's like, give me the ice cream. baby's happiness is just, it's not quite happiness yet, though. It's just anticipation of happiness, which in some ways is another form of pain. So there is a little bit of misery here, but it feels like things are going in the right direction. And the hard-working single mom, she leans down and she hands the ice cream cone to the baby. The baby, with its clumsy hands, is grabbing for that ice cream cone, and then he has it, or she has it. I didn't narrow it down by gender yet. Okay. But then it topples. The ice cream falls off of the cone onto the ground. And now I've narrowed it down to maybe 2 cases. And I'll narrow it down even to one single case of this happening in the world right now. It's on a hill. They're on a hill. The ice cream cone, the ice cream ball starts rolling down the hill, and the little baby is like toddling after it on his clumsy legs, and it falls down the ground and then I'm sorry. I'm starting to really feel the misery now. The ice cream rolls down the hill, and the baby knows it's not going to have ice cream today. Even that little baby knows that this is not the day for ice cream. That's a lot of misery, but it gets worse. Okay, the ice cream rolls to the bottom of the hill, and there's some ants down there. There's an ant hill at the bottom. And the ants start swarming on the ice cream. Oh, now they're getting happy. So maybe there's like a good part to this story. But it's mint chocolate chip ice cream, and those ants hate mint chocolate chip, so their day is ruined too. So that's it. It's misery for everybody. The baby, the mom, the ants. And now you know. Now you're connected to the misery that's happening in the world. And you've done that exercise, and it makes you a better person. All right. So now, let's get to demoing. All right. So here's what I'm on right now. I want to make the camera smart, and I'm on the way. I don't think this is going to be a tale of misery. I think this is going to be a tale of joy and jubilance and other synonyms for joy. So this is an editor. It's not within the game, but it's a tester that I wrote. It's like a little diagnostic object that calculates, by the algorithm I came up with, what is the best position for the camera to be in. And I spent a lot of time explaining this algorithm, so I'm not going to go into a lot of great detail on it again. It's in the first session if you're interested. But one of my constraints is that either the camera should use a straight down angle or it should use a tilted angle. So there's always kind of a binary decision. Are we going to go straight or tilted? Straight or tilted? Most of the time, it wants to do tilted, because tilted looks a little better. Tilted actually looks a lot better. But sometimes you need the straight angle to kind of see down into the ravine. Now it also averages out the camera distances from the neighbors, not averages, it uses as input to the algorithm how low might my camera have to go if I move in one of the 4 directions from where I'm at now. And it'll use that to take the chosen camera position and bring it down a little bit closer. So if I was not next to an overhang, this little ball here represents where the chosen camera position is. If I was not next to an overhang, the camera position would be up here at the ideal spot, according to me, for my game. So ideally, if there wasn't an overhang there, I'd be way up here. But since I'm right next to an overhang, I know that on the next step the player takes, they might go underneath of it. I'm hedging my bets a little bit and saying, let's bring it in a little bit closer. Okay. Let's just bring it in just a little bit closer. than if I weren't close to the overhang. And as soon as the player goes under the overhang, then I have to pull in closer, and I can, it's no problem. Okay, and that's my new camera position. Okay, now there's some other algorithmic concerns that I'm just not talking about yet, because this is a demo. This is a demo of something that was recently accomplished. So I have this pretty good algorithm for choosing for one square where the best position for the camera is. Now there's an older algorithm I wrote about 1.5 years ago that works just fine, but it's not as good as this one. And in this session, I intend to hook up the camera position controlling code to use this new algorithm. So I'll be able to see the difference between the old and the new in this session with just a tiny bit of luck. Like, I've got 3.5 hours before I need to stop doing this and move on to some other tasks that have nothing to do with the game. Cleaning my house for a guest, basically. Alright, so that's it. That's what I'm up to. I'm going to start the work right now. Alright. So it's a complicated enough task that I'm going to write out a plan for how I'm going to do it. This design stuff up here that was from the previous session, let me simplify it a little bit. Number 1 is what I went with as far as my different options. Okay, I'll put this under settled. Raycast up to find best camera angle. Okay. Let's say deferred. Pathfinding. Okay. So the next task is going to be to hook up camera to new raycast algorithm. Get rid of all this. Okay, next part is I got the player follow guide there. Here, since I'm going to make some destructive changes almost certainly, let me do a git commit. Put those in so I can revert back if I need to. Okay, I kind of hate this dichotomy between player follow object and player follow guide. There's a lot of stuff in here I would just like to be rid of. I don't even like the names of these things. I think I just want to create a new class. Call it camera positioner. Okay, and that's a fancy word for move. Camera mover. Mono behavior attached to camera. It's going to have some kind of interface. Okay, props. What props do I actually want to keep here? The smooth factor thing. This is, I already have a long-standing to-do. On this to make it frame rate independent. I kind of copied and pasted some code early on in my Unity learning period, and it just worked. But it's an example of a highly prevalent solution that a lot of people use that is junky. It's not frame rate independent. So but there's also, like, how much do I want to bite off here? So let me split this out into two tasks, or let me defer one of the tasks. One of the tasks would be updating the target for the camera. That's the one I'll do. And the other one would be having a frame rate independent way of moving to the target. And that one I'll defer. I don't need to solve that in this session. It would make sense to solve it later, particularly because I want to come up with a camera path mapping algorithm at the same time. Okay. It's gonna have on board changed. That's one way to do it. The trouble is there's two types of events I need to respond to. One is the player changing their position, and the other is, and this is really for later, the other is updating a cached set of raycast results in response to visual obstacles changing. I say visual obstacle meaning, like, if a door closes, that could make it so that the raycasting to figure out the best camera position changes as well. So onboard changed can serve the purpose of updating the new player target, because I can get the new player target from the board changing. But it can't serve the purpose for efficiently updating that map. So the question is, do I want to have a different interface that's specific to the player moving, since I can't use onboard changed to do anything besides changing the target of the camera? I think it should be no, I think this is right, actually, because I still need the board object in order to determine which square is near the player that player can walk to, which influences the camera angle. So if the player is right next to a wall, I'm not going to evaluate the camera positions inside of that wall. They're off limits to the player. So I need the board. From the board I can get the player position. I could make the argument that I shouldn't call on board change. I should call on player position changed if the intent of this is going to be to change the target of the camera. But I might as well perform that calculation inside of this function of whether or not the player position actually changed, so that the calling code can be a little bit cleaner. And further, I'm not committed to this, but I may in the future have the recent changes to visual obstacles be kept inside of the board data structure, and if that were the case, I could use onboard change for that. So okay, onboard changed is, I think, the right interface to be called. Okay, it will set a new target based on algorithm. How can I forget how to spell algorithm? Algorithm. Oh God. Terrible. Algorithm. Sometimes I just lose it. I lose algorithm. There. It's in my fingers. It's in my muscle memory, which is weird. If I think about it, I can't spell it. So the new target based on the algorithm. Trivial check for no player change. Player chord change. Okay, and then update, keep same as before. Refactor methods, recasting methods to static camera mover methods, and have camera space analyzer call them. Yeah, so I can put all this stuff inside a camera mover. My life is better. There, you know what? There is actually maybe a better place. I'll say number 2. Same as number 1, but camera util has raycasting methods. casting and other targeting path finding methods. Yeah, because it's not here yet, but I'm going to have that path finding algorithm and just having a utility class that can be used to find the information without it all being inside of one thing is going to be better. Particularly if I've got a camera mover and I've got a camera space analyzer and they're both using some of the same methods. It's a little more natural and easier to maintain to have the third module with these utility methods pulled out into them. Because otherwise, if I'm in camera space analyzer, I'm calling camera mover this method or that method, it implies that I'm doing something with camera movement. I'm not actually. So yeah, this is better. Like, it's not really worth keeping two separate options. So let's say okay. So are there any other ways to do it that are worth considering? Okay. Number 2. I'm writing it out to be open-minded and to make sure I'm not missing a good idea. But at first glance, I don't think this is the right way to go. It's kind of like sweater thread pulling. Put raycast values in a data structure. Use that data structure for neighbor averaging, for neighbor checks. Okay. So +1 for performance, +1 for getting closer to pathfinding, -1 for writing, -3 for writing a lot of code before I'm very confident in the camera behavior, in the camera moving behavior, in the camera target finding behavior. Okay. So I'm not going to do this one, but I should be ready. I should be ready to make my raycast checks that look at all the neighbors to see optimal positions from them. I should be ready to replace that later on with something that grabs from a data structure that has stored those values. So I think number 1's fine. We're just doing some due diligence. I think it is the best thing to do at this point. Yeah, I'm gonna move on it. I'm gonna start it. And also I get to delete player follow object and player follow guide. After it's given me good results, I'll do that. After alright. So go up to camera. Before it's over, camera util may get broken out into multiple classes too. So you don't want one super giant class with every possible camera utility thing in it, but for now it seems like just one will do. Just start by moving some of these guys over. So the algorithm needs calc tilt vector, calc straight vector, shortest raycast distance for neighbors. This favor tilt weight should just become a constant. Let's see. But really, like, all of these can be condensed. Like, how much of this visualization tool am I actually going to use in the future? I mean, am I going to keep coming back to this thing? Or is it really just going to be get me the right camera angle and then it'll just pop in that way? You know what I can do? I can do it like this. I can start off with a single method in camera util, a single public expose method that returns the optimal camera location. And then the visualizer can use that. And if in the future I find that I want to expose more values, then I can change interfaces. But I'll start out with the most encapsulated set of functions there. So that means I get to pull most of these guys in. This I'm just going to delete. I'm not using it. There's another one I'm not using up here. Yeah, the average ones, I don't really think I need them. You're not getting called by anybody, so let's take you out. No callers. Okay, all that. Yoink. In here. I don't need. That's public anyways. I do need to make. I don't even think I need this favorite tilt weight, because I think on average it's gonna give me tilted, all other things being equal, just the way I have it set up. I view it as a embarrassing shortcoming of an embarrassing shortcoming of C# that you can't have static constants. Okay. So I want one that works with the board and one that works without it. All right, so let's do vector 3 floor position. And let's also say that if none are specified, we'll pass God, so weak at times, C#. You're saying that you're unwilling to let me use an initialized static variable as a default option for a parameter. You're just confused by that, huh? There's no way you could compile that. There's just no way you could do it. I say no. So I say no. You're good, right? Well, if I can have it default to null, that means I can pass null. No, that's okay. It's okay. All right. So we'll say I gotta move some stuff over from here. I got the floor position already. Oh. So I'm returning a vector, but that requires one extra calculation. And it seems like it might be a redundant calculation. Oh wait, no, I've got them right here. Okay, never mind. I don't have to recalc. Okay. Yeah, that would have been a redundant calculation. So we'll return either. No, I can't yet though. Okay. just write this out the inefficient way, and then I'll decide if I want to optimize it. Okay. No, it's more than that. Okay, so it's gonna be I need the head position. Damn it. Alright, that's not too bad as far as optimization goes for performance. Trying to keep this code in reasonable performance shape. I don't want to do too much here, but I want to start off well. Okay, what are you saying? Oh, yeah, fair enough. Alright, there's enough code here, it's worth writing some comments. I hate this shit. Oh, okay. Let's see what you got. Oh, okay, I guess it is nicer. I take it back. I thought I was going to say something stupid. Always in these learning moments with writer. So what does that operator do? The coalescing. So it says that we're either going to take check neighbor deltas if we've got it, but if it's null, let's go ahead and use something to the right of this operand. This coalescing operand. That's a good name for it. Coalesce. I like that. I wonder, just for language learning, could I just add another one? I could. So I could put a whole bunch of them together and it would just keep comparing left to right, and I think just take the first one that is non-null. I think that's how it works. Okay. That's not the right word. Okay, so that's pretty good. Let me see everything I've got here, if I can just change this guy over to use the refactored code without too much trouble. Say transform position and just leave those null. Okay, so this should get a lot simpler. Yoink. Seems pretty good. I'll move this over to a better home. All the action is over in a different module now. Camera util. Woot woot. Here's where the party is. Okay. Wait a minute. This gets called or not? Who's calling it? No, it does get called. Never mind. Okay, I'm guessing this bool value is never used. Yep. Just take this off. Oh, void. Same for you. Okay, let's see how that's done. Cool. It is showing a tilt position. It's only showing one line now, but it is using the refactored code. Now if I want to see a whole bunch of them all together, I can just duplicate this. There we go. This should be an interesting visualization. Yeah. So it's all tilt. And make sure that that it works down below too. Yeah, it's interesting. So I start pulling it down, and then it's going up a couple as I get to the floor. I've got two that are up and two that are tilted. And that's probably good. it is doing something where it's checking inside this wall and getting a value that's knocking this guy down, but I'll fix that. Alright, also let me just, okay, delete those. And this thing, I'm going to prefab it, unpack it. Let's rename it. Camera Analyzer. Camera Position Analyzer. Camera Space Analyzer. Okay. Nice thing about that is I can also make updates to all of them at once if I've got a whole bunch of them laid out. Okay, so that's step one. I've got everything refactored. Step two is going to be to create this new camera following class and have it use that logic as well. But I'm going to grab myself another cup of coffee and bring it back up. And that's just going to take me a couple minutes. I'll play you a song while you're waiting. Now they don't fly, they crawl. Made them small. Okay, so we got the camera util. I said I was going to make a camera mover. I already like the name much better than player follow and player follow guide and all that. So. Let's just copy all this over and then I'll delete and revise and everything. Okay, so we go. This stuff I can all delete. This I can delete. Delete. Okay. Yeah, that's a weird thing here. A rotation is getting set based on the rotation of the player? Why would I do that? I don't need the max Y. Oh, okay, I get it. I get it. So I need some of this stuff and not all of this stuff. Let's see, we've got target position, and target rotation. I think I'm going to stop saying rotation for Euler angles. I think I'm going to start a new convention. Let's call it Euler, and then I'll... Ludicrous! It's going all right. Like deep into a algorithm I'm excited about. What's going on with you? Sure. What's your project? It's a game, I'm guessing. I think you told me something about it before, but I might have forgotten. Let's see. Okay, so I'm also going to want... Take out this. I just won't have the player transform. Dark Souls, famous for being unreasonably hard. There was a game I made called Drod, and one of the reviewer quotes on it was, "This is the Dark Souls of puzzle games." Because it was so fucking hard. And it sort of doomed the game to being like a cult classic or a niche, super niche favorite, because people that are really huge into making puzzle games would, or playing hard puzzle games would love it. And then the vast majority of people would be like, what the hell? It's breaking my brain. Anyways, you do like a Dark Souls, I think it's like a first person, you against hordes of enemies, dungeon crawler type thing. I never played it though. I think I read some reviews or watched some walkthroughs and was entertained, but it looked way too stressful for me. Board chains, and then I need to set a new target based on the player. So for that, I want to get transform, player transform, this board, get I might as well get the player piece too. Let's see, let's get player piece. It's not impossible. Like, but if you wanted that, I'd say, I don't know how many games have you released. And if it's 0, then I'd say I make a small game to start. I don't know. Do whatever you want, but I could make a whole giant Dark Souls game. On the other hand, it's what gets you excited too. So if you pick a project that gets you excited, then you're more likely to follow through with it. 0, yeah, I get it. I think I've just had a few games that towards the beginning that were more than I could hope to complete, and I did better when I picked smaller games. But yeah, and the other thing is, like, the difference between when I made a game back in the 90s and you making a game now, to get people's attention, is about 10 times harder. So like you would have to make a pretty awesome indie game to get somebody to review it or put it on a Let's Play, or I admit it is pretty tough. I don't know, art games, those ones sometimes get lucky. Let me see. So I need to figure out from camera util the best camera position for player transform position. Leave it at that for now. And that's going to be target. Did I typo it? Apparently so. Yeah. Okay, this I can just get rid of. Cool. Problem with that is I think the default vector 3 is 0, 0, 0, and that could be an actual coordinate on the board. So let's say bool is target set. Have you got a name for your new game yet? Okay, this is where you're at currently. This is the target position. This is where you're at currently. This is where you want to rotate to. Yeah. Work's kicking your ass a bit. You'll get to it though. It's always fun to start. It's always so fun to get started. And it's the middle part Actually, I don't know if that's the middle part. I think it's just starts getting hard right in the middle, and it only gets harder from middle to end. That's why I try to not do all the fun stuff right at the beginning. I try to just kind of lay it all out in a steady way. So if I see any bugs in something I'm working on, I go and fix them before I go into the new feature. Otherwise, it just becomes like this hateful thing. Unless I just got to keep it all good and stable and steady all the way through, or it's demoralizes me. Okay, so this will go from there to there. That's probably fine. I need to get the rotations in the mix too. So this is not enough stuff being passed back. Let me think about what I want to return. So let's go out. It's not a Euler though, it's a direction vector. It's a normalized vector. So let's make another constant for the Euler. So let's see. Actually, I might want to instead. Let's see, let's do this new vector. Let's make this be 350, 0, 0. I think I need to do something different. Let me go look at my old code. Which has got these guys here, which I know worked before. Okay, that's my tilt for and the other one going straight down. There we go. Okay, it's more likely to work. I don't know about this stuff here though. So then camera mover will now have target position, target Euler, oh, I gotta pass other stuff in. Player, dang it. What am I missing? Okay, there's the position. Next one, ow. Okay, so this won't be neighbor positions or neighbor deltas. Okay. Just one other thing I gotta incorporate. So target Euler. How'd I do it over here? That's the tricky part for me. So I've got the player transform has Euler angles, and I added the camera rotation to it. I don't know why I did that. I think I was just being symmetrical, but in a brain dead way. Let me check. Pretty sure that for the player, I will never rotate. Where are you, player? Here you are. I'll never rotate the top level game object. I'm going to rotate the offset underneath of it. Yes, yes, yes. Okay, good. I don't need to bring over that piece of cruft into the new code. So find neighbor deltas. I guess I don't need the player piece after all. Let's go. Okay, so public vector 3, not public, static, find neighbor deltas. I'm looking at some similar code that I might reuse or refactor or borrow from. Show walk squares. Alright. I think I can reuse this and it will be a good thing. So let's make it public. Let's document how it works. I know I've got an error in here. Come on, where are you at? There it is. Yeah. Okay. Cool. So then come back over to here. Okay, so let's see, board. I just call it delta. If height is not equal height's infinite depth, that means the player can walk in that direction, so I want to make that one of the directions that is evaluated for camera positioning. What? What? Dang it. Okay, maybe this is not the one I wanted to use. Walk square deltas. Okay, that's a different one. Oh, and here it's saying look at 0, look at... I'm making these non-public. I'm not going to use them. I don't want to evaluate that one. Okay, then let's make another one. goes along with it, which is neighbor offsets. This gets hard. Leave that for now. Take that out. Okay, so walk deltas. Okay, I think I got it. This one will be 0, F, 0, F. And this stupid thing is getting in my way. I cannot see the thing I want to reference. Okay, dr negative 1 means Z1. Okay, that would be south. No, that's north. Okay. New vector 3. What do we got? South coming up here. Okay. And west. East. Then I want a new vector 3 do a numerable vector 3. So I don't want to be allocating memory all the time, so I'll make a static list here of vector 3s. Neighbor offsets. Ah, God damn you. there'll be, for now, a maximum of 4. Okay, so if that's true, then we'll say clear neighbor offsets here at the top. Wasn't a clear? I thought it was a clear. Oh, I didn't do this right. List. It bugs me that I keep on running into situations where I'm allocating new memory, and it's actually a lot of hard work to not allocate new memory all the time. So if I'm allocating memory right here in the static, no big deal. If I allocate down here, and this is code that gets called multiple times a second, and then the frame updates. So I don't want to keep on allocating, because then I end up getting garbage collection kicking in, and that'll reduce my frame rate. So it's a lot of work to write code this way. I really wish C# or Unity had some better features to just make it so it was easier, but so if I add a new vector 3 here, I'm allocating memory. I don't want to. I'm pretty good about not doing that. So let me see. I can have this be put us back to an array. Okay. And we'll have this thing returned just the count of used elements in that array. Let's call this, let's see. dy equals the new height minus the player height. And I'll say that if the player is dropping down, I don't want to observe that. So if dy dy is less than 1. Continue without adding that. Okay to evaluate, going up, downstairs, but not falling. Okay, and then I need to increase my added count here. Okay, now return the added count. Oh man, that's the tricky part. Because then I gotta send this thing off to data structures. So let's say T creating a data structure that will allow me to avoid resizing or re-initializing elements in the array. And capacity. Elements equals new T capacity. come back to camera over. I can change this into a fixed array. So we say static fixed array vector 3 neighbor opt. Damn you. Like that. Okay, so then we say could implement IEnumerable on it too. I don't think that would be too hard. So then if I go to piece group, I've got an example of that. No, that allocates though. I'd rather not use that. Okay. camera util. I can do a fixed array here. Yep. Okay. Where am I at now? Okay, floor position. What is this? Find best camera position. That doesn't seem right. Okay, camera util. Oh, okay, right. So let's move this back. So it's here. And I know I broke this guy. I'll fix that up again. Maybe I'll just make an overload on this function that doesn't need all the same params, because this one is only used for some analysis, so that wouldn't be hard. I'll just make a little syntactic sugar here. this one will make a fixed array as well. Fixed array. What? Oh, yeah. Just delete that. Will that work? No? How can I remove it? Without... Yeah, that's what I have. Oh, interesting. I didn't know about this. You put an underscore by itself. Is that something about C#, or is that just a convention? Oh, okay. So that's a lot of code changes. I'm curious if this still works. Let's see, this should be out, vector 3, camera, position. Let's make this blue. Okay. God damn, that's a lot of code changes. Let's see if I have regressed. Actually, okay, it must be errors. Yeah. Oops. Eh. Okay, set. Let's put it back how it was. Not JavaScript. Oh, I guess it is. Huh, okay, cool. Okay, set. Okay. So if I just do set. Got it. Okay. So here I can say that if the index is greater than the count, to increase the count. Make sure I don't access outside of what's actually set. Okay, so this is pretty close to working like a regular array now. To find the problems I just caused, let me just compile. What? It's not worth the changes I made. Not worth it. Not worth it. Not worth it. This is not important. I'm trying to make it all slick. Waste of time. Alright, fixed array. Make these public again. This is bullshit right here. Just get rid of it. Garbage. You're garbage to me. And redundant. Okay, build again. Okay. Come back to Unity. Okay, that has not regressed. Good. Alright. I don't know, Ludicrous, if you're still on, but this is the thing. This little line here, it's showing where the best camera position is for this particular square. There's a fairly clever little algorithm I wrote that raycasts up to locate the best position. And it'll switch between two different angles as appropriate. Ooh. Okay, so now I want to see it not on that little diagnostic object, but on the actual camera. Okay, so that means onboard change has to get called. To set the camera mover. Wait a minute. I changed something up here. What was that? I'll find out. Compilation errors will get it for me. which one is the player guide? I think that's messing me up because the player follow guide and there's a player guide, and I think one of them is legit, another one I'm about ready to delete. Yeah, player guide is the one I want to keep. Okay, so remove the player follow guide. And up here I gotta add back in player guide. I also feel like I might have lost something useful from that. So let me get status, get diff, main object. Well, let's see what I deleted, so I can put it back in exactly the way I had it before. Player guide equals new player guide. Okay. So I do need that to be there. And I do need this to be here. Okay, put that back. What else? Start. Player guide equals new player guide. Pass the transform, pass the board. Okay. Then I think that'll be fine. Okay, that should be fine too. Okay, getting close to trying it out. Real close. Very small chance of it working the first time I try it. Tiny, tiny chance. Okay, so stuff I don't want. This is player follow object. Hold on to the smooth factor though. Okay, remove that. Add component, camera mover. Really great chance that I break all of this when it starts up. So let's say there's a 20% chance of it working right the first time. I'm gonna take a bathroom break. I'll be right back. There'll be time for music later. Got work to do. Got work to do. Got work to do. All right. Scary moment when I hit play and everything breaks. Here we go. Only a 20% chance of this working right the first time. I have no idea what it's doing when it's all doing it with all the spinning and everything. It just doesn't. Okay. That wasn't too bad of a start. It began without initializing to the right angle. Something feels off. I'm not sure what it is yet. Okay, there's some kind of reversal. Something's off. No. What is off? It feels like it might be calculating the position of the camera based on the last place you were at instead of the current place you were at. 'Cause these angles aren't bad. Then I'll go up. Yeah, and then it goes the tilt. I think that's it. I think I nailed it there. This is an interesting case. I'll come up over here. Ah! Yes! It found the overhang. It moved the camera up over to avoid the overhang. Good for it. It's doing relatively well. got that one issue. Yeah, see, camera did not move at all, but the next step that I take, it'll move down. Yep, I'm one behind, that's all it is. It's making me pretty happy. I've got a bug that won't be hard to fix. Okay. Console ran clean, very nice. Okay, I'm close to having it. Okay, so here I know that the board changed, and it was updated here. The issue is that the effects have not been performed yet. And this needs those to be performed to move the transform. Okay, so we say if board changed. Okay, the other one I found was the initial position. Just say camera mover. See, the board has been loaded. Let's just give it an init method, and for now it can do exactly the same thing as on board change. Well, I can do a little bit better than this. Let's say 1. And actually, it'd be nice if I just change this to update camera target. That. So I only really need to do it one time. And I can rename this to is initialized. Yeah, that's what I want. Okay, got that. And back in main, I need to pass board to my init. That's probably gonna do it. I think that fixes the 2 bugs. I'm gonna give us a 98% chance of working the first time. Feeling confident. Okay, the camera came to the right position after loading. Okay, here it would be nice if it... No, I guess I'm not there yet. Up one more. Okay, here it would be nice if it tilted down to let me see around the corner. That's something to think about. There it tilts to, sorry, I said tilted down, but here, what I mean is, here I'd like it to take the straight angle so that I can see around the corner. Right now I can't see around the corner at all. So I don't know where I'm going when I go to the east. I think I might have seen it go down a little bit late. I'm going to go back up there and check that. Let me look at this again. Did it drop? Feels like it didn't drop. Yeah, it dropped late. The camera height didn't go down right away. Yeah, camera height came late. Why is that? Everything else seems to... X and Z seem fine. The camera height is taking one extra turn. That's right. Okay, I remember why. So it takes more than one processing of the effects to move the player transform to the lower location. So turn that volume down, it's a lot. So when I go over the side, there's two effects that are queued up. One is to move the transform 1 square east, and the second effect is to move the player transform all the way down to the ground. And it does it in 2 separate frame updates so that the trails will show a movement like that it goes zoop and then down. So if you look at the trail, you see it goes at a right angle and then continues down. My code is looking at the first updated location from the transform instead of the last. That's fixable too. It might require a little bit of thought. So I've got 2 bugs now. I just want to write them down. In case I see a third bug, I might forget the first 2. Okay. Where's my bothering me file? That. Okay, first one was can't see adjacent square around the corner. Okay, second one, multi-part. Okay, multiple effects to update player transform will only show first transform change in camera movement. Okay, let me keep testing. I've got those 2 captured. They won't be too hard to fix. Go up to that overhang, because that's where there should be some new magic. Alright, so now it's more conservative about ducking down underneath. It knows that it can tilt and see me underneath this overhang still. Then I come down there and it ducks under. But before, here I am standing under the overhang, it would have ducked underneath of it. It's actually a nicer experience that it doesn't duck underneath, because I'm still quite visible. It's only when I go one more step forward that it needs to duck under, and that's definitely an improvement to the algorithm. I want to see if it has like the averaging. Whoops. Oh, what's that? I cannot. Oh, I know why. The editor object. I've got like a diagnostic object there, and it messed up the depth scan. Okay. Not seeing any averaging there. Well, I'm kind of wondering how important it is. It's not really that bad of a thing to kind of to go straight up or down through an object. So when I go through that overhang, as soon as I clear the floor, I'm just looking straight through faces with normals reversed to me, and it looks right. It doesn't look wrong. There's probably a tiny glimpse that's possible of some geometry that's not right. But, I mean, I can't see anything. Like these overhanging pipes, I might be able to just catch the barest glimpse of them at some time where it's inappropriate, but it's pretty clean. That whole thing with the smooth duct under the overhang, I don't know how important that is. It might actually be a worse experience. But still, the intent of this code was to have an average around here, where I split the difference between the highest camera position that it could go to and the one it would need to go to when I ducked under. So I'm curious why I didn't average there. There might have been a good reason. But I want to know what it is. This is looking pretty bug-free. It's faster than the old code. It's supportive of path mapping, which I haven't written yet. I'll work on that tomorrow. I think if I fix those two bugs I spotted and maybe get some explanation for the lack of averaging, then I'll be fine for this session. And it's 3:42 now. I got 45 minutes to do that. Okay. So if I look at this guy, if I pull him out to here, he just goes all the way up. That may not be all the way up though. I kind of lost track of where the top of it is. Let's see. No, there is averaging here at least with the diagnostic. This guy be ignore raycast. That'll fix that one problem I saw. Okay. Jeez, come on. You don't have to do a major delay on every stupid little thing. What are you even doing? Okay. So that's working. It probably has something to do with checking the neighbors. Which might also be related to this problem I have over here where it's impossible for me to see the neighbor here. Let me check that it's actually able to see the neighbors. Okay. No averaging at edge of overhang. And let me fix this one first, because I know the cause of this problem. So one thing that I don't need to use the transform to get the position. I could get just the location of the player. For that, I say CRH equals let's say Jesus. Static vector 3 last player better last player CRH. Also say that if nothing moved, I don't have to do any work at all, and that's going to be much faster. CRH equals last player CRH. Do I have an equal operator on it? I'll check in a sec. Just return, don't do anything. Otherwise, we update last player CRH to be CRH. Okay, vector 3 player position CRH util just get rid of this part. Let's see how that flies. This shouldn't be stack. This be that. Okay, let me see if I fix that one problem before I move on to the next. Yeah, I think I got it. You guys are really annoying. I'm not even trying to do anything with these two guys. They're just dogging me. I don't think this will have any effect on the overhang, but I'm just going to try it. Just see what's up. I love how it doesn't duck under there. And there it does. Let me try killing myself. Yeah, it's working good. So let me fix the other stuff. Okay, that looks healthy. Okay, checking west. I'm thinking the height. It might be giving me a relative height already. Well, I'll see. Let's see. What are you giving me? 290? Okay, no, that's an absolute height. What's my player height? 290. Okay. Okay, DY should be 0. Yep. Oh. This is the problem. It should be a -1 comparison instead of 1. So let's try it again. It should be a whole different experience with that change. This is a lot of new code here. I'll go ahead and walk through it once. DY 0. Keep going this time. Okay. What does neighbor offsets look like now? Good. It should just populate all of these, all 4 of them. I'll just go up a level, see what it actually does. Okay, so the neighbor deltas, oh, have to assign it. Good, count 4. All set. I think correctly. Alright, let it play. Nope, still not. Okay, I think I'm starting to get it though, because it did an adjacency check, but it needs a little more information than the distance in the adjacent square. So if an adjacent square requires an angle to view it, then that needs to affect where you're at prior to moving into it. So here it should already be at the straight angle so I can see to the west. Likewise, here it should be at the straight angle so I can see the square to the east, which I need to walk into. Now I'll go upstairs and I'll check the overhang. It should have that averaging. See, so there's the example of it going through the roof where you can see a little bit of junk geometry. This pipe here that goes underneath, you're able to see it briefly. It's just not enough to worry about on its own. There might be other stuff where the effect is much worse, I don't know. Ah, that's cool. I think I got... Yeah. Okay, it gets ready for you to go underneath there. But I don't know if it's splitting the difference. Oh, it is. It is, okay. Is that helpful though? The split the difference thing, I don't know if it's actually helpful. Because alternatively, it could be showing you more of the screen. When it moves in like that before it actually needs to, ironically, it obscures more of the screen. Because it brought the overhang closer to the camera, so it obscured more of the camera. So I think I'm going to disable the averaging thing. I gotta think about this though, because I'm trying to write general code that does the right thing in many situations, not just the ones that I happen to be testing right now. In some ways it's kind of nice. It gives you a premonition that you're about to have the camera view go underneath. But I think it's just obscuring, so I don't think it's good. the more important case to handle that I'm not handling now is when you can't see an adjacent square that you're going to move into with the chosen angle or height, I suppose. Okay, so camera util. I don't think averaging is good. You want to use the best possible one, so let's yank that out. There's one other way I can do it, which is just go for the shortest neighbor distance. I think that is actually the better of the two. Let me just see what that looks like. So I lost that really cool thing where it would stay at the better tilt angle until I absolutely needed to be underneath of it. So before, I think I was able to go at least one in. Yeah, I think I was able to go one more in before it ducked down. Here, yeah, it's ducking early. That's not what I need. Okay. So gotta rethink this a little bit. 30 minutes. Let's say that I need to find, if I'm in this square here, this middle square right here, I need to check each adjacent square. Let's see. Check each adjacent square to see if it's visible. And only think, how exactly do I do that? I could shoot a vector. I could shoot a vector down from the calculated center position to each of the 4 target squares and see if I hit anything. I have to calculate the right angles to get to them and everything. Could also, this is more of a proxy, it's not an exact value, but it'd be kind of cheaper and easier and cacheable. I could run the same calculation as I have from the center square on each of the adjacent squares. And if any of the adjacent squares needed the safe angle to see them, not the safe angle, the straight angle, I could use the straight angle. Trying not to get killed by edge cases, or I should say special casing for one thing, and then there'll be some other situation that comes up and it won't handle it right. I'll have to special case for that, etc. It feels really close to being a good general purpose algorithm that works for most everything. All right, let me start writing some different approaches. Okay. This is all done. The hard thing is not detecting if I'll be able to see the adjacent squares or not. The hard thing is deciding what the correct action is if there's an adjacent square, or the correct adjustment to the camera position to make if there's an adjacent square that can't be seen from the first one that I've picked. So in some cases it might be right to bring the camera in closer to see the adjacent position. In other circumstances it might be more correct to change the angle. And for corners it's going to be a straight angle that allows you to see it. But for other situations, the straight angle won't allow you to see it. It'll be a tilt angle. So that's the tricky part for me. But let me keep on working through some different options here. This might be a bit of a hack. It might not cover all the cases, but could have it grow. Say, if any adjacents, choose straight angle, use straight angle for center square. That doesn't seem bad. It seems pretty pretty general. Like it'll probably cover most of the cases. There's going to be some that maybe it doesn't. I don't think it's going to be too bad though. Okay, number 2. The question is, which point am I ray casting up towards? Yeah, so the thing I don't like about this is I end up solving for an equation that could be solved different ways. There might be something to that, but it doesn't seem promising to me. It'll take a lot of thought. I'm going to do number 1 first. I think I can do that in the next 10 minutes. And here I'm just going to say use this tilt. Okay. Position equals okay. I already got that. Tricky. No, that's okay. That's okay. I'll pass in a value, which means don't check any of your neighbor deltas. Otherwise, it'd be this flood fill. It'll be a never-ending recursion. Okay. So let's see. I could get a little bit smarter and check west and east first, but I'm not going to worry about that right at the moment. So optimize, check west and east first, specialized function that doesn't do every calculation. I feel like I'm forgetting something, but I can't remember what it is. Oh, you gotta get rid of all this junk down here. Okay. So I can get rid of this best comparisons. Let's just say Alright, go ahead. Do it for me. Oh, you're gonna make me do it. Okay, no problem. All right. This might work. I really hope it does, because I'm getting short on time here. I gotta start cleaning my house. I promised I would. I'm a promise keeper, you know. Oop, let's unplay that right away. Something didn't go right. And actually I've got some evidence already of a problem with this guy, because it's not drawing anything. There must be some console errors. Oh, okay. Stack Overflow. Okay. Okay. I must have I must have some kind of infinite recursion type of a thing going on. Oh no, 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 don't. Let's what's the safest thing to do here? Everything's saved. If I have to force quit, I'll force quit. Here we go. Call stack. This is 2 levels deep. So the neighbor count should be 0. Uh-oh, it's 4. Okay. That's because I'm using the static value here instead of the 1 past 10. Okay. No problem. No problem. Run. Stop that. Okay. Glad to catch that before it crashed anything. Okay, my array came back. So if I come up here, yep, it's going straight up. Okay, there's a good chance this works. Okay, the debugger's not running. Just hit play. Yeah. This is good. I love this because I can stand there and it's not ducking under. It doesn't need to. It doesn't need to duck under anything. So just let it be there. Here it ducks. That's fine. Okay. No ducking. Yeah. Okay, cool. No ducking. Duck. Okay. I'm not saying this is the end of all the camera logic, but it's a good foundation. I'm in a better place with it than I was with the old code. And I'm excited to move on to the next part of it, which will happen tomorrow. So I'm declaring victory for the session and stopping the stream. Stop.